I am Assalamu alaikum. I am Muhammad Binuddin Robi. First of all, I thanks to my Honorable Iftikhar Alam Ifat sir, Assistant Professor in IIT NSTU, to give me a opportunity to make a presentation on a research paper which is using deep ontologies in formal software engineering. Now I am going to present my presentation based on this paper. It is a paper presentation. The objectives are introduction, purpose of the study, usable DUF framework, term ontologies and HOL terms, queries, invariants and proof supports, proof morphism on ontologies, application and related work, future direction and conclusion. The introduction of this paper is the challenge in modern software engineering is to link formal and informal content to support advanced search, classification, and validation. Ontology, which are structured representation of knowledge, play a crucial role in achieving this integration. Usable DOF is introduced as a tool designed for creating deep ontologies. It proves continuous validation and integrated documents that including text, code, definition, and proofs, facilitating traceability and navigation. This tool is particularly valuable in domain like safety critical software certification, which requires traceable and consistent documentation, such as in the CEN, ELEC, and common criteria standards. The purpose of the study is to design the and implemented a robust framework that uses ontologies to enhance the creation, management, and validation of formal software engineering documentation. These address critical needs in certification, consistency, and integration, ultimately contributing to the reliability and efficiency of documents in safety critical system. Now we are discuss about the usable DOF form of framework. First of all, usable HOL is executed by usable DOF to support formal ontologies development and document generation. Secondly, ontology defined language is introduced to define ontologies within the usable environment, enabling strong typing and integration of metadata information while formal content. And third, anti-quotation are used to create symmetric reference between formal and informal content checked on the fly for validity. The next slide we are going to discuss about the term annotation and HOL terms. The first of all we are discuss about the term annotation. A key innovation is usable DOF is the use of higher order logic HOL terms for metadata and constraints. This avoids the need for a separate metadata language, allowing logical reasoning over ontological relationship. On the other hand, HOL terms is that usable DOF supports term context annotation which logical term enabling powerful query capabilities and validation of symmetric relationship. This both term annotation and HOL is the most important in ontology. Now we are going to discuss about the queries, invariants, invariants and proof supports. First of all, usable DOF support symmetric constraints on documents structure through HOL invariants which enforce conditions like traceability between claims and evidence. Secondly, the framework includes built-in support for querying instance of classes defined in ontologies, checking them against logical constraints and verifying the integrity of documents. And thirdly, the framework allows for the formal verification of relationship between ontologies, making it possible to prove the preservation of constraints across different ontology mapping. Then we are going to discuss about the uh, proving morphism on ontology. The most important part and a crucial important thing in morphism. There are two types of goal we are when we are proving a morphism on ontologies. The first goal is the use of usable DOF for proving morphism demonstrates the framework's ability to handle complex relationships between ontologies while ensuring that all relevant constraints are respected. And the second goal is the approach also shows how deep integration with a proof assistant like Isabel can provide both logical verification and execution of document structure, enhancing the reliability and traceability of formal software engineering documentation. The next slide, we are discuss about the application and the related work. The application and related work we can divide it into three nodes. The first node is usable DOF contents with conventional ontology language like OWL by being deeply integrated into logical environment, allowing for both executable code and formal proofs. The second note is the tool support a document-centric view enabling hypertext-like navigation within usable IDE and automatic document generation. And third note is the author compares usable to relate efforts, highlighting its advantage in expansive and validation compared to languages and system focused on symmetric web or object-oriented data. Then we are going to our next slide where we discuss about the future direction. We can divide it, we can select it three type of future direction. First is usability improvements, functional enhancement, and domain expansion. First of all, usability improvement such as a deeper term anti-quotations and formal interoperability. The second of all, functional enhancement like a real-time previewing and incremental document generation. And third of all, the domain expansion to broader fields including re-engineering traditional ontologies and supporting advanced search in formal proof repositories. Then we are going to discuss our conclusion of this paper presentation, which is Isabel DOF is positioned as a groundbreaking tool that bridges the gap between formal and informal content in software documentation. Its deep integration into the Isabel ecosystem and emphasis on machine checking constancy provide a strong functional for creating, validating, and mapping formal documents in a wide range of application from certification to mathematical proofs. Thanks to all to hear our presentation, and again thanks to our honorable teacher to give us opportunity make a paper presentation using based on using ontologies and mathematical terms. Thanks to all.